OpenMPParallelLoops. OpenMPParallelLoops is a work-sharing construct based on distributing loop iterations on parallel threads. This is a major construct in OpenMP. So here is an example. In that case, I want this loop to be executed in parallel. So I add the pragma OpenMPParallel4 to execute this loop in parallel. And in here, I say that this j variable is private. I don't need to say that n is private because n is only read. And if you remember well, course on parallel loops, this is actually a parallel loops. This loop will be executed sequentially on the thread. So somewhere, what I'm doing, if I have 3 threads, okay, I'm going to distribute, for instance, from 0 to n over 3 here, minus 1, n over 3 to n over 3, etc. over the threads. So each thread will execute a subset of the loop iterations. This is another syntax. If I have OMP parallel blocks, then I just put 4, an OMP4 to get a parallel loops. But this is really similar to the previous syntax. The parallel loops take scheduling clause. Okay, so that can be static, dynamic, guided, or you can specify that at runtime which one you want. So this is then given by your non-environment variable. But this is not different from the other scheduling. It's just a way you provide that to the directives. So let's look at them. So the first one is a static one. Okay, and it takes static to indicate you want a static scheduling as a clause, and it takes a chunk size. So here this is an integer. Let's assume this is equal to 2. So in that case, what is going to happen is that this chunk of 2 iterations will go to the first thread, the second thread, and second thread, third thread. This one will go to the second thread, this one to the third thread, this, etc. And in the end, it will go. And there is no change in the allocation. It's always like that. So if I take this 1, 2 in here, it will go on 1, etc. So there is no change. It's a static allocation of the iterations over the threads. Another version, it's the dynamic one. In the case of the dynamic scheduling, I'm always again taking a chunk of size 2. Okay. I will allocate the chunks dynamically over the thread. So at the beginning I put it here, this one in here. This one with 2 threads with a static scheduling would have to go there, but with a dynamic one, because this thread is available before, goes on this thread. So somewhere you try to take into account the fact that computing a chunk of iterations doesn't always take the same time. So you adapt the scheduling in order to try to get some load balancing in the end. But for the dynamic scheduling, the chunk size is always the same. If you want something different from this point of view, you have to go to guided. In the case of guided, you start with some size for the chunk. Okay, in here I did put 3. Okay. You dynamically allocate them on the thread, and when you're done, you start to decrease the size of the chunk. Okay. And in the end, you have only one iteration on that example to execute. The idea again is to take into account the fact that you will have different execution times for the execution, and you want to achieve load balancing, but you want also to minimize the number of chunks you have. So at the beginning you start with big chunks, and at the end, to get the load balancing, you end up with small chunk size. So the questions: take the code in this directory and use the static chunks and make different values of it and see how it influences the execution time. And in here, take a few loops, let's say 3, and you convert them into parallel loops and run them in parallel using OpenMP. If you want to do more exercise, you can go to this tutorial. There is a lot of material on the web on OpenMP, since it has been around for a long time now. And see you in class.